Welcome back, guys, to this end of the lesson control structure. Today, we are going to look at the repetition, also known as the iteration or the looping control structure. Repetition is a programming construct that allows a block of code to be repeatedly executed for a specific number of times or as long as the truth value of a condition is unchanged. So that is what we call repetition. In this case, what are we talking about? We have a block of code which can either be executed for a specific number of times, that we know the number of times the block is going to be executed, or it's going to be executed as long as the truth value of a condition is unchanged. There exist two different types of loops, the count controlled loops and the condition controlled loops. Just from the name, you can already guess count control loop it is based on a count, and a condition control loop it is based on a condition. Let us enter deep into these different types of loops. Count control loops, also known as definite loop. This is a loop in which a set of instructions is repeated a specific number of times. So when we're talking about a block of code being repeatedly for a specific number of times, we are talking about the count control loop, which is also known as a definite loop. It's a loop in which a set of instructions is repeated a specific number of times. This specific number of times is the counter, hence the name count control loop. The types of count control loop that we have are the for loop and the for each loop, where we shall be introducing ourselves to programming, where we shall be studying the language C and Python. We are going to examine the for loop in C and the for each loop in Python, because the for each loop is a loop that we can see in Python but not in C. Okay, we shall come to that later when we shall be introducing programming. This is the syntax for a pseudocode when it comes to a count control loop, that is for. There are two different cases. For, we have our counter equals to the minimum value, because here we know the number of times it is being executed. It can either be executed from a minimum to a maximum or from a maximum to a minimum. So for this case, we have for our counter from the minimum value to the maximum value. We repeat these different tasks, then we proceed to the next counter. Otherwise, if you are leaving from the maximum value to the minimum value, if you are using pseudocode, it is advisable for those who might be dry running your algorithm to better understand. If you are leaving from a maximum to a minimum, it is preferable to say for counter equals to max down to minimum. What should we do? We repeat this task, then next counter. So if you are leaving from a minimum value to a maximum value, it is 4, 2. But in case you are leaving from a maximum to a minimum, it is 4 down 2. So that we understand that in this case, the counter is changing by, is increasing, and here the counter is decreasing. When it comes to the flowchart, it is true that the flowchart of a for loop is similar to that of a while loop, which we are going to see after this. So let's understand how it goes about. This is the flowchart for a for loop. We have the initialization, the condition, the repeated statement, the update. But now it will be very important for you guys to understand how you can map these particular values to this flowchart. Let us proceed. When it comes to the initialization, this is what we are talking about. So if I'm converting this to a flowchart, my initialization will be that counter equals to the minimum value that I have. If it is in this case, counter equals to the maximum value. If we are talking about the condition in this case, if we are leaving from a minimum to a maximum, then my condition should be what? Counter less than or equals to maximum. But if you are leaving from a maximum to a minimum, my condition should be counter greater than or equals to minimum. When it comes to the update, in this case, next counter, as we said, we are increasing, so it should be counter increment. So we are incrementing the counter. And this can also be written as counter is equals to counter plus 1 or counter plus 2. It depends on by what value the counter is increasing. At this level, the counter is instead reducing. That's what we're talking about. So guys, it is very important for you guys to know how to map the pseudocode to the flowchart and vice versa. As you can see, I use different colors for you guys to easily memorize it. Then the initialization, the condition, and the update. As you can see, very important. We move to the next one, the condition control loops, also known as indefinite loop. Indefinite meaning we don't know the number of times you are actually looping. These are loops in which a set of instructions is repeated based on whether a condition evaluates to true or false. So in this case, you can already see that even on condition control loop, we are having two types, because when we were defining a repetition, we said a block of code is executed either a fixed number of times or as long as a truth value is unchanged. But under condition control loop, we are seeing that a set of instruction is repeated based on whether a condition evaluates to true or false. This loop can still be divided into two categories, where we have the pre-test loop and the post-test loop. Pre-test loop, also known as the while loop. This is a loop type in which the condition is tested at the start of the loop, hence the name pre-test. So we test the condition first of all before we enter the loop. The statements in the loop are executed if and only if the condition evaluates to true. Now, this is the pseudocode of a while loop. As you can see, while we have our condition, what should we do? We repeat these different tasks and we end while. For the flowchart, this is what we have. So when we enter here, we have our condition. If my condition is true, what do I have? Repeated statement. If it is not true, I come out of the loop. And look at this, how the repetition takes place. After repeating this, I am going back and testing the condition. So I will keep on being in this loop so far as my condition will be true. And when it is false, I come out of the loop. The post-test loop, also known as the repeat until loop. This is a loop type in which the condition is tested at the end of the loop. The condition is tested at the end of the loop. The statements in the loop are executed if and only if the condition evaluates to false. So here it is the contrary. We keep on repeating until our condition is true, which is not the case for a while loop. This loop is sometimes referred to as the do-while loop, but it is the same thing as the repeat until loop. This is a pseudocode, as you can see. So we repeat. These are the repeated tasks until we find our condition. So that's why we have the name post-test loop, because this is pre-test loop. I have my condition before I execute. Whereas here, I execute before I come and test the condition. For the flowchart, this is what we have. So I have my repeated statement first, then I have my condition. Is my condition true? No. That is how I keep on being in this loop until my condition evaluates to yes, as you can see. Now, let us look at the differences between a post-test loop and a pre-test loop. Otherwise, the while loop and the repeat until loop. First of all, for a while loop, the condition is evaluated at the start of the loop, whereas in a repeat until loop, the condition is evaluated at the end, as we can see here. In a while loop, my condition is evaluated first before I execute, whereas here I execute this statement before entering in the condition. The next difference, the repeated statement may never be evaluated, whereas here the repeated statement is always evaluated at least once. Very important. When we come here, if I come here, if my condition evaluates to no, I come out of the loop without executing this repeated statement. Whereas as I enter here, I first of all execute, and if my condition is true, I come out of the loop. And as I come out of the loop, this statement must have been executed once. That is why we have this difference that in a while loop, the repeated statement may never be evaluated, whereas in a repeat until loop, the repeated statements are always evaluated at least once. Another difference, the repeated statements are evaluated until the condition is false, whereas here the repeated statements are evaluated until the condition is true. The repeated statements are always evaluated until the condition is true, as you can see here. If my condition is true, I repeat. If it is true, I repeat. Whereas here, if my condition is not true, that's when I perform the loop. So these are the differences between a while loop and a repeat until loop. Now, when we come to the concept of loop, it is very important for you guys to know that each of these constructs can be nested. The selection in a repetition, a linear in a repetition, not repetition. Problem. So what do we mean here? I can have a while loop inside an if construct. I can have an if construct inside a for loop and so on and so forth. When we shall be writing programs, we are going to come across such examples. Okay, a very important concept when it comes to loop is what we call an infinite loop. What is an infinite loop? It is a loop that never terminates or ends and repeats indefinitely because the condition to stop the loop is never met. That is what we call an infinite loop. A loop that never terminates or ends and repeats indefinitely because the condition to stop the loop is never met. This loop These loops are created when a condition in the loop never evaluates to false. For the case of a repeat until, when it never evaluates to true. Okay, what causes an infinite loop? It can either be an incorrect loop condition, that is a condition that never evaluates to false. If you take the case of a while or a for loop, if I say while true, because remember that at this level, if my condition is true, I keep on repeating. So if I say while inside here I have true, is true equal to true? Yes, until you will never stop. So these are some of the conditions that makes a loop to be infinite. Or if I say for I equals to 0, 2, negative 2. Remember that if you are using this particular syntax for and 2, it means that we are leaving from a minimum to a maximum. And we all know, mathematicians that you are, that you will never, there is no positive number that you will add to 0 and at a point of time you will have negative 2 because the increment we are having here is always positive. In case it is negative, we talk of a decrement and there is no positive integer you will add to 0 to get negative 2. So this loop will keep on evaluating and the value of I will keep on increasing until infinity. Since there is no positive number you will add to 0 to have negative 2. So these are some of the conditions, these are some of the incorrect loop conditions that bring about infinite loop. Another case is a missing or incorrect update statement. This happens in a for loop when programming. For example, if I say for I equals to 0, I less than 10, you realize that in this case, I did not precise how I is changing because this is at the level of programming is for you guys to understand. In programming, especially in C, I will say for I equals to 0, I less than 10, then I specify that I should be increasing by this value or this value. And now, in case I do not precise this, it means that the value of I does not know how it's going to behave, whether it should increase or it should decrease. And as such, I will remain 0. And since 0 is always less than 10, that is how we are always going to have an infinite loop for this case. Take note that in the pseudocode for I equals 0 to negative 2, the update of the counter is already included. So that is why I use this case like in programming. In pseudocode, when you say for I equals 0 to negative 2, we already know that when you use 4 and 2, we know that the counter increases by 1. That's how it is by default. In case it should be increasing by a different value, it has to be specified. Improper break statements. Missing or unreachable break statements in loops that rely on them to exit. When we are using loops, especially in programming, there are some keywords that we use to come out of a loop when a particular condition is met. And if such are not present, it becomes, in some cases, we might have our loop to be indefinite. Note, the break keyword is a control flow statement that terminates an entire loop immediately, exiting to the next statement after the loop. Another control flow statement is the continue keyword, which skips an iteration and proceeds to the next iteration. More emphasis will be done on these keywords under programming. What are we saying here? For example, if I am looping for I equals to 0 to I equals to 3, if I have a condition in the loop that says when I equals to 2, break, What does that mean? When I will be equals to 2, I am going to leave the loop and I'm not going to perform the iteration for I equals to 3. But if I say for when I is equals to 2, continue, it means that the operation that was to be done when I is equals to 2 will not be performed, and instead I will move to the iteration to be done when I is equals to 3. That is the use of this particular keyword, the break and the continue. And as I said in this NB, more on this will be emphasized when we shall be treating programming. I will encourage you guys to like, follow, and subscribe in such a way that when the time comes, you don't miss the event. Another case is recursive calls without base case. You better understand this when we shall be treating recursive function. When you have a recursive, if you create a recursive function and there is no base case, then the function is going to loop forever and you will never have an end. Recursive functions with undefined or unreachable base case lead to infinite calls. How does infinite loop terminate, or how can you terminate an infinite loop? External events like shutdown. Your program might be executing infinitely for indefinitely. Their loop might be executing indefinitely, and if there's a shutdown, for example, if it's a desktop, the shutdown will terminate the loop, meaning that when you power on your computer again, the loop won't be there again. We have resource constraints like memory runout, stack overflow, or resource exhaustion. For example, let me take the case where you're having a computer that enables you to to write a program that can take a maximum of 100 megabytes. And if you write a program and in your loop, there are variables that are being created that consumes memory. As long as the loop will be executing indefinitely, that is how many variables consuming memory will be created. And when the memory of the computer will, and when there will be a run out in the memory, there might be a crash that will cause the computer to shut down or to pause, and this will terminate the loop. Another case is forced closing of the program. Under programming, we are going to have cases of infinite loop, and when it is executing, a simple closing the program will terminate the loop. That's what we call forced closing of the program. That is, the program does not terminate on its own. You are the one forcing the program to close. These are the cases where we can have an indefinite loop. This is the end of control structure. I hope you guys understood the concept of repetition. We shall lay more emphasis on it when we shall be doing dry running and conversion of algorithm, which is the next lesson. I will encourage you guys to like, to subscribe, and to share the link to your classmates in such a way that our community can grow and more solutions to your problem will be delivered through this channel. Thank you very much.